All right, so we're here working on Chapter 6, example problems with our stats class, and we just finished doing letter B, asking percent of cars that get less than 15 miles per gallon. So we're focused on this normal model that has a mean of 24 miles per gallon and a standard deviation of 6 miles per gallon. We sketched the model to show you 3 above and 3 below in terms of standard deviation. So now we're on to letter C. All right, what percent of all cars get between 20 and 30 miles per gallon? Again, what is right in the middle? 24. So 30 is actually exactly 1 standard deviation above the mean. So I don't actually need to calculate that z-score. I know that has a z-score of 1. Right? Because 30 minus 24 over 6 is 1. If you don't understand that yet, that's okay. We'll do the work. But I already know that that's exactly 1 standard deviation above the mean. Now, 20 isn't. 20 is a little further down, so I don't know what that z-score is going to be. So I'm going to find that z-score. All right, so let's find it. So we have z equals 20 minus 24 over 6. So what is 20 minus 24 divided by 6? I know it's a negative. 2/3, right? So 0.6 and then a repeating bar. And we'll show the work for 30 as well. And you'll see that the z-score is 1. Okay, any questions on finding the z-scores yet? Everybody okay? Okay, so now watch how I write this one. We want to find those percentage of all cars between these two numbers. So I'm going to be shading in the middle. So I'm trying to find that area under the curve. So I'm going to write down for my z-scores being less than 1, but greater than negative 0.6 repeating. Is everybody all good with that inequality here, this compound inequality? Again, I'm not that concerned about the notation, but you know as well as I do that the more you focus in on the small things, the little details, all right, the better you're going to understand this. All right, so I always focus on, okay, what does that notation actually mean? Z-scores between those two numbers. Okay, so now we're going to go back to Z-score calculator. Okay, now the one we just did, for those listening at home, the one we just did together was only shading to the left. So that's why we clicked to the left for the input. But now we have shading in the middle, and there's 2 options. It says middle equal area and middle different areas. Analyze your curve that you did here. Is that the same on both sides of 24? No, 1 is a little bit further, right? 30 is a little farther away than 20 is from the average. So it's not going to be equal. So that's why we're going to check or click middle different areas. Middle different areas. Okay? And if you mess this up, if you try to click middle equal areas, it's going to make the numbers the same for your z-scores. And you don't want that. Okay? So middle different. Our first one was negative 2/3. 6. Okay? And then our one to the right was 1. Oh, it's not working. Sad. Right. A lot. It doesn't matter. I was just being silly. How come mine's not working? Is yours working? Did it change it for yours?
The more 6s you add,
the less it likes it. I'll just do a couple. That way it doesn't get mad at me. It got mad at me for doing so many. Is it? How many 6s did you use, Jarvis? No. The more 6s actually is better. I stopped using so many because it was getting mad at me when I tried using these. It's all good, guys.
58.9.
Which one did you use? Listen, sorry. And what did you use for the right Z-score? Does it look like this? Or is it just one of them?
No, it looks like that.
Okay.
So I just keep it at 0.66.
No, it shouldn't be that different. There you go. You had to click away. It wasn't changing it yet. Make sure you click away first. This is really good for those of you guys listening at home trying it with us. Make sure you click away first, and then it will update. All right? Because Leslie F just had that issue where it wasn't. And you don't want to get the wrong problem on the test because you're not clicking away. Right? Famous! They don't know who it is, Leslie F. I just said Leslie F. They don't know who that is. Okay. Let's move on. Oh, I'm sorry, I just put the answer. What was it? 0.58 minus 0.587. But again, you can have something different. Totally fine. So 58.7%. If you got something that's a little bit off, that's okay. Not a problem. Not a problem. Everybody good on finding the area that's shaded in the middle? Okay, awesome. All right, let's see where I want to go because I got like 10-ish minutes. I want to try a couple of different ones. Okay, I'm not going to do D, so you can do this one on your own if you like. This is really similar to B, but now you're shading for more than 40, so you'd be shading to the right. To the right. Okay? I want to do E. Let's do E. Describe the fuel efficiency of the worst 20% of all cars. Okay? So the worst 20% is going to be somewhere down here. I don't know what the Z-score is, but how much area is shaded down here? 20%. So what is that as a decimal? 0.2. All right? Now the other link that I emailed you, the other link is going to allow us to find that Z-score. Now, you should be realizing that we already were given the area. What have we been calculating in the problems before this? We've been calculating the percentage in the area, the shaded area. All right, now we're going backwards. So if you noticed in that link, it talks about doing inverse normal probability. So this is going backwards. All right, so do you guys see where it says find the corresponding Z-score for a probability? I feel like I have to zoom this one in. That's a little small. Zoom, 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 zoom. Everyone see it? Okay, do you see where it says 0.1? We're going to change it to 0.2. We know mean is 0, standard deviation is 1, so that's going to spit out a Z-score. All right, do you guys see right here where it says probability for the left tail is Z is less than negative 0.842? That's our Z-score. So I'm going to write that down. Z is negative 0.842. I'm going to pause to make sure we're all good. Everyone see how we found that? No? Yes? A question? No? That's the Z-score. It says on there less than Leslie F because we're shading to the left. See how we're shading to the left? So any car that has a Z-score that's less than negative 0.842 is going to be in the worst 20% of fuel efficiency for cars. Okay? Which I'm going to go on a limb and say, Guillermo, yours is in that shaded area. Okay? All right, so, I know, harsh. Let's go ahead and write down our formula again. Z equals Y minus mu over sigma. We now have a Z-score. Negative 0.842. Do we know what fuel efficiency goes with that Z-score? We don't. So we're going to be solving for Y. Minus, our mu is still 24, and our sigma is 6. And oh snap! We have entered the world of algebra. I know, right? We were, but today, oh man, today we're right in it. All right? So we're going to multiply both sides by that 6 and get y minus 24 equals something. negative something. So then y is going to be equal to all of that plus 24. All right, so whatever that is. Hit me with it when you got it. I heard 18.95. So 18.95? Okay, great. Okay, so any person who goes to get their car inspected and finds out that their fuel efficiency, after it's been test driven by the dealership, their average fuel efficiency is less than 18.95, so basically less than 19 miles per gallon. That's in the worst 20% of all cars in the state of Texas. Okay? Sorry, Guillermo. All right, you're probably in the worst 5%, but that's okay. We're not going to get specific yet. Okay, I'm going to pause here. Any questions on how to do it? Going the inverse, the backwards way. This is called inverse normal because we went backwards. Why did we find y? Why did we find y? Because before we knew y and we found the percentage in the shaded area. But now it's the opposite. They're saying, here's the percentage in the shaded area, 20%. Find the z-score and use this z-score to find the fuel efficiency that's associated with the worst 20% of all cars. Okay? Everybody good? Okay, let's do two more, and then I'm done. We're almost there. Two more. I want to skip to J, the last page. Skip to J. Okay. So we just looked at a problem, all right, that talked about the worst cars in terms of fuel efficiency, the worst 20% of all cars in terms of their fuel efficiency. But now we're talking about this lobby group wants no more than 10% of all cars. So no more than 10%. So here's 10%. To be under 20 miles per gallon. So they're telling us that this value here is 20. And if you shade to the left, so anything below that, only 10% of all cars should have fuel efficiency below 20 miles per gallon. Okay? So the first thing I think of, well, if this is 10% and it's shaded, what is the z-score? All right, so let's go to our calculator link. The second one, to do inverse normal. And we're using 0.1 this time instead of 0.2. Let's see if I got the same thing. Negative 1.282. Excellent. So we're going to write down negative 1.282. All right, so that's my z-score. And we're using this formula. Now let's read the problem to make sure we know what we're doing. If the standard deviation does not change, so what was our standard deviation on all the problems so far? 6. When we standardize, it is 1. But before standardizing, it's 6, right? So I know this is going to be 6. I just found the z-score. What do they want me to find if the standard deviation does not change? What average fuel efficiency must be attained? They're asking us to find the average. That's mu. That's mu. That's the mean. So I'm going to plug in negative 1.282. We did have a mean, but now this lobbying group, this ecology group is saying, hey, we want you to change the bottom 10% to be no more than 20 miles per gallon for fuel efficiency. Basically, right, to help out our cars and hopefully, in turn, the actual Earth that we need to save. All right, because in 20 years we won't be here. Anyway, so if they change that, we got to change something about the cars. So they're saying, okay, make all of the cars more fuel efficient. All right, so we got to make all the cars more fuel efficient, which means that the average is going to change. So we have 20 minus mu over 6. And again, we've stepped back into the world of algebra. This is fun. Just want to do a lot of parentheses to confuse you. See if you can get it. What is the new average that they need to come up with for the fuel efficiency for cars in Texas? You got it, Catherine. What is it? 27.7 miles per gallon. All right. Now, how does that 27.7 compare to the original average of 24? It's better, right? And that's a good thing. Our cars are more fuel efficient. Any questions on J? Yes, Leslie. Yeah. Yes, the answer, whenever you're trying to find, like, the first problems we did was finding what percent. That one, the units is percent. All right. For these questions, it's asking to find a new average or a data value, which would have a units here of miles per gallon. On ZScore, yes. I don't have any units ever on my Z-scores. Yes. Yes. Leslie? No, just kidding. Let's do K, and then I'm done. All right? I know. Okay, I'm sorry. I'll do K, and we're done. Now look at what they're saying in K. We're telling the people who make cars, make your cars more fuel efficient. And you probably can guess what the people who make cars are going to say. No. Right? Not going to do it. So they're saying, okay, no, but maybe we can get to 26. Okay? Maybe we can get to 26. Not 27.7, but 26. So if we have the worst 10% of all cars is still at 20, what was that Z-score? Negative 1.282. So this is the worst 10%. Now it wants us to find what standard deviation do we need in order to attain this no more than 20 miles per gallon for the bottom 10%. So let's do the formula again so our brains can see what we know and what we don't know. We know a Z-score. What's our Z-score with 20? Negative 1.282. And those are linked, right? 20 and this Z-score are linked. So if I write the Z-score for 20, what's going in Y? 20, because they're linked. What is the mean that the manufacturers say they can attain? 26. So that is our new mu of 26. Over, and here's where we had 6, but now they're saying, what standard deviation do you need now? Well, I'm going to write sigma, but you can write x. It doesn't matter. I mean, I would prefer you write sigma. Okay. I prefer you write sigma so you know you're solving for the standard deviation.
Yeah, I was like, never mind.
Okay, I'm not ever going to kill anyone over sigma. But don't even test me about mu. Okay, so we have, did a little algebra here. I moved sigma over to the other side with multiplication. I did a little subtraction in my brain. 20 minus 26 is negative 6. So if you divide both sides by negative 1.282, we know we'll get sigma. I'm almost done. I'm sorry. Almost done. 4.68. So 4.7? Excellent. Thank you. Okay. Now, once you do this, I want you to put your pen or pencil down. Once you have this, you're like, we did it, excellent. Just be like, I'm going to just sit and relax for 90 seconds while I kind of summarize what just happened here. Okay, so pen or pencil should be down. Don't worry, it's all being recorded, right? You can watch it later. Okay? So, we just said that for our new sigma, it's 4.7 miles per gallon. What was our original one? Our original sigma was 6. Our original average was 24 miles per gallon. But now they're saying we can do 26 miles per gallon, which is better, but that means our sigma is smaller. Okay, so let's think about that. If this is 26 now, and we're going up, and to make it easier, I'll just make it rounded up to 5. If our sigma is 5, then we have 31, 36, 41, 21, 16, 11. So what happened to our bottom ones down here? If you go back to the original, the very first one we ever did, it was 6. Now, a z-score of -3 is 11. That's good. We don't have any cars, in theory, that have below 11. Do we have cars that have below 11 miles per gallon? Of course we do. But those would be considered unusual. They're past the 3 standard deviations. Okay? But take a look at the high end. Do you see how we have 41? What was our high end to start? Went too far. It was 42. So even though it's a little bit shy of 42, what we've done by lowering sigma is our data is not as spread out, which is both good and bad. All right, it's good because our lowest cars are not as low. But it's bad because our best cars are not as good. Barely, right? Barely. Right, and I also round it to 5. So it really should be lower than that. All right? So it's one of those things that there's always 2 sides to every coin. Okay? So it's helping on the low end, but hurting on the top end. All right, any questions about how to find any of this stuff with the calculator, computer, any of that? Because you're about to try on your own. Are you ready? Oh man, I'm so excited for you.